resources and its origin. What is mineral resources? Mineral resources are useful for the world. It is the volume of rock enriched in one or more useful materials. So meaning these minerals is valuable and importante talaga ito sa world kasi nga useful ito or napapakinabangan. The word mineral can be any substance that comes from the earth such as sand, salt, and stones. The word mineral can be any substance that comes from the earth such as sand, salt, and stones. So we have two major categories of mineral. These are metallic and non-metallic. So sa metallic tayo. These where metals are extracted. Hindi naman bago sa atin yung metals, diba? Alam naman natin kung anong itsura nito. These are things like gold, silver, zinc, copper, and marami pang iba. So proceed tayo sa non-metallic. These mineral have no metallic shine. So ibig sabihin madiatoy nga na silang. Tapos, and it break easily. Ibig sabihin ng break yan, hindi yung break ng magjowa, yung break ng naputol, ganon. These are things like sand, fluorine, coal, and sulfur. So let's proceed to the next. Ores. It is the body of material which one or more valuable substances can be extracted economically. It can be mineral or rock. So ito yung pictures ng mga ores sa mundo. Sige, palakihin natin. So ayan yung mga examples ng ores. Bauxite, beryllium, fluorite, gypsum, talc, topaz, chromite, cobalt, gold, halite, iron, mica, molybdenum, nickel, sulfur, and uranium. So we have ore deposits. These consist of ore minerals that contain the valuable substances. So dito nakapaloob yung mga ore minerals which nagko-contain ng valuable substances nga. But not all minerals do contain valuable substances. That's why we have this gangue mineral. These are minerals that occur in the deposit but not contain the valuable substance. So basically, they are waste or worthless. Ibig sabihin nun, walang pakinabang. Ganyan. So ito yung itsura ng gangue minerals. Yan siya. Yun yung waste lang or patapon. So we have origin of mineral resources. First is the magmatic ore deposits, hydrothermal ore deposits, sedimentary ore deposits, placer ore deposits, and the residual ore deposits.
Magmatic ore deposit. What is magmatic ore deposit? A magmatic ore deposit is an accumulation of magmatic minerals. Some of these minerals extremely rare and almost never encountered in common rock. An example being alloys of the platinum metals. Other minerals, such as magnetite, are common and can be seen in many thin sections. They form an ore deposit when they accumulate in large amount and unusually high concentrations. In short, in magmatic ore deposit, also known as orthomagmatic ore deposit, which deposit within igneous rocks or along the contacts in which ore minerals crystallize from melt or were transported in a melt. The ore deposit that are formed in and around igneous rocks unit as a result of mineral participation from aqueous solution. What are the minerals that can we get from magmatic? There are three oxide or minerals that we can get from magmatic: chromite, magnetite, and ilmenite. Chromite, a brownish black mineral that consists of a mixed oxide of chromium and iron and is the principal ore of chromium. Magnetite, a gray-black magnetic mineral which consists of an oxide of iron and is an important form of iron ore. Ilmenite, a black mineral consisting of iron titanium oxide, of which it is the main ore. The process of magma is magma evolve in magmatic systems. Magmatic system is the site of melting, which means It is the oath way of magma migration and site of crystallization within a specific geological and tectonic environment.
So para mas maintindihan, here's a video clip about magmatic process.
At a destructive plate boundary, the denser oceanic crust is subducted beneath the continental crust. The slab of ocean crust mixes with the mantle and rises up into the crust, where it collects in large chambers. The pressure in the chambers builds until it forces the magma through vertical dikes and horizontal sills. It finally erupts through a volcanic vent as lava. Water evaporates over the ocean to form clouds that move inland. These precipitate rain over high ground, causing erosion and transporting the sediment down streams and into rivers, until it is deposited on the continental shelf, gradually building up the landmass. At a destructive plate boundary, neither plate is subducted. The rocks become buckled in a concertina effect over a large area. The mountain range grows as rocks are forced upwards, and simultaneously the root of the mountain is forced downwards into the mantle. At a constructive plate boundary, where a rift occurs, magma forces its way to the surface of the crust, melting and compressing the rocks above. The valley collapses and creates a series of faulted steps. Finally, the magma forces its way through weak points on the valley floor and erupts, flooding the valley with lava. The area subsides, enabling water to collect in lakes that eventually join together to form an ocean.
So, basically, na-form yung magmatic or kapag nag-occur yung volcanic eruption. So, pagkatapos na sumabog yun, lalabas yung magma, and yung magma na yun is titigas siya doon, and yun na, maka-form na yung magmatic or deposits doon.
Sedimentary deposits are formed through the erosion, transportation, and redeposition of minerals that can survive the rigors of transportation. The most common is silica, which forms a number of materials, including silica sand, sand and gravel, and flint. The precursor is igneous quartz, example in granite, and then the sedimentary deposit may undergo metamorphism and recementing to produce quartzite. Sand and gravel for construction use is extremely common, and production is more dependent on local markets than availability. Certain areas are, however, noted for producing industrial sand that is sufficiently pure to be used in the manufacture of glass, ceramic, sodium, silicate, and the like. What are the minerals that we can get from sedimentary? Some beds of marine sedimentary rocks contain enough metal to be considered bed is rich in lead, zinc, copper, iron, oxides of iron, and manganese. Sedimentary process was formed or either through the selective removal of non-metallic component or by concentration of heavy metallic grains form placer ores. Placer gold examples are accumulates along streams where currents are too weak to carry the heavy flakes of gold but strong enough to winnow ordinary rocks fragment. The rock at the surface of the earth is subjected to weathering and leaching. This is the process that turns rock into soil.
Here is the video clip on the formation of sedimentary ore deposits.
Crystalline igneous rocks crumbled under the action of water, wind, and temperature fluctuations. Finely divided rock material, transported by wind, water, and ice, settled at the bottom of water basins, together with the remains of dead aquatic organisms. The thickness of the sediment layer steadily increased over time. The lower layers were compressed by overlying layers. The pressure exerted by the upper layers also squeezed water out of the lower layers and caused the crystallization of salt, which bound the loose deposited particles like cement. The sediment slowly changed into a hard rock. The type of rock that was formed in this way is referred to as sedimentary rock. Sedimentary rocks cover about 75% of the area of the Earth's continents. They therefore occur commonly, but do not form such thick layers as igneous rocks. A cross-section of a sedimentary rock often shows multiple layers, reflecting the history of the rock. The younger layers always lie above older layers.
So, ayun nga, napo-form yun during processes of sediment entrainment, transport, and deposition. So, ibig sabihin, sa entrainment, yung gaya nga nung nandun sa video clip, yung rocks is nag-crumbled into the edge of the water. Then, it transported by the wind, water, and temperature. Tapos, pumunta siya dun sa water basins and kumapal yung sediment layers for a period of time. Then, the lower layer compressed and yung pressure sa upper layer is nagdulot sa sediments para mag-slowly change to a hard rock and dun na-form yung sedimentary. Good afternoon to each and everyone. My name is Mary Grace S. Dairo and I will be able to discuss the mineral deposits and their origin. This includes the hydrothermal ore deposits and the placer ore deposit. Hydrothermal ore deposit, or what we call hydrothermal mineral deposit, are accumulation of valuable minerals which form from hot water circulating in Earth's crust through fractures. They eventually create rich metallic fluids concentrated in a selected volume of rock, which become supersaturated and then precipitate or minerals. As shown in the picture of geothermal area, the hydrothermal deposits are produced when groundwater circulates to the depth and heats up by coming near a hot igneous body at depth or circulating to great depth along the geothermal gradient. Such hot water can dissolve valuable substance throughout a large volume of rock. As the hot water moves into cooler areas of the crust, the dissolved substance are precipitated from the hot water solution. If the cooling takes place rapidly, such as might occur in the open fractures or upon reaching the body of cool surface water, then precipitation will take place over a limited area. It results in a concentration of substance attaining a higher value than was originally present in the rocks through which the water is. So what type of environment where we can find hydrothermal ore deposit? The deposits are hosted in limestone or dolomite that was deposited on shallow marine platforms and tectonically stable intraplate environment. So, ayan nga po, naka-underline yung environment kung saan natin matatagpuan yung hydrothermal ore deposit, which is the intraplate environment. As expected in such environment, volcanic rocks folding and regional metamorphism are absent as general rule. Here are some pictures of hydrothermal ore deposit. So, this picture shows the process in which hydrothermal deposit takes place. Such hot water can dissolve valuable substance at low concentrations from rocks. As the metal-enriched hot waters move into cooler areas in the crust, the dissolved substance may start to precipitate. As for the geologic settings of the ore formation, any concentration of metallic minerals formed by precipitation of solids from hot mineral ladder water, or what we call hydrothermal solution, flowing through fractures and pore spaces of rocks. The magma chamber is the heat source of the hydrothermal solutions, which contain both magmatic and meteoric matter. So, kaya po tayo nagkakaroon ng hydrothermal solution. It is because of the magma chamber, because it serves as the source and contain both meteoric or magmatic matter that helps to create hydrothermal deposit. So, another picture of geologic settings of hydrothermal process. And lastly, or the last picture that also shows the process. The hydrothermal ore deposit is divided into 6 subcategories that are porphyri, skarn, volcanologic massive sulfide (VMS), sedimentary exhalative or SEDEX, epithermal, and Mississippi Valley type. So what is Pyrex type ore deposit? It is formed in hydrothermal fluid circulation system developed above and around high level sa volcanic felsic to intermediate magma chambers and or cooling pollutants. While the skarn deposit is an ensemble of ore and calc-silicate minerals formed by mesomatic replacement of carbonate rocks in the contract auroral of a pluton. The third one is the volcanic-hosted massive sulfide. They are predominantly stratiform accumulations of sulfide that precipitate from hydrothermal fluids or on below the seafloor or a wide range of ancient and modern geological settings. So, in the hydrothermal, more on po siya sa magmatic, so because it serves as the source of the heat. The fourth one is the sedimentary exhalative deposit. These are the ore deposits which are interpreted to have been formed by release of ore-bearing hydrothermal fluids into a water reservoir, usually the ocean, resulting in the precipitation of stratiform ore. Next is the epithermal. Epithermal is a term retained from an old system of classifying hydrothermal process based on the presumed temperature and depth of deposition. So epithermal is what we call it is a term retained from old system, and as you can see, the term thermal refers to the temperature. Next is the Mississippi Valley type. It is a one type of lead ore deposit and first found in the mid-continent United States in the valley of Mississippi River. So what are the key factors in the formation of a hydrothermal ore deposit? There are 4 key factors. These are the source of metal, source of fluids, trigger of fluid circulation, and the site and mechanism of precipitation. The source of metals includes magmas, volcanic, and sedimentary or metamorphic rocks. The source of fluids are the magmatic water, meteoric water, connate water, seawater, and metamorphic water. The trigger of fluid circulation includes heat source, compaction, tectonic deformation, metamorphic dehydration. And lastly, the site and mechanism of precipitation are the fractures, cavities, porous rocks, temperature decreases, pH, EH, or composition change. The types of minerals found in hydrothermal ore deposit. These are chalcopyrite, Cu, or which we call copper, sphalerite, zinc, and hydrothermal ore deposit. These are chalcopyrite, Cu, or which we call copper, sphalerite, zinc, or Zn, galena, Pb, or lead, silver, and gold. The dominant gauge materials are quartz, pyrite, and pyrrhotite. Lenses of barite, gypsum, or anhydrite are associated with the sulfides and some deposits. So, to sum up, hydrothermal ore deposits involves the magmatic fluids that serves as the source of the hydrothermal process. So, in this hydrothermal process, the magmatic fluids causes the water to heat up in order to produce or to deposit minerals
that is, or what we call hydrothermal, from the term hydro, which mean water, and thermal, which mean the temperature. So now let's proceed to the placer or placer ore deposits. In geology, a placer deposits or placer is an accumulation of valuable minerals formed by gravity separation from a specific source rock during sedimentary processes. So, as you can see, magkaiba po yung pinanggalingan ng placer ore deposit at hydrothermal ore deposits. So, kung sa hydrothermal, ang source niya is yung magmatic fluids. In placer ore deposits naman, it is formed by the gravity or from a specific source of rock during sedimentary process. Okay, so the name is from the Spanish word placer, meaning alluvial sand. It also may be defined as superficial mineral deposits formed by the mechanical concentration of mineral particles from the weathered debris. The mechanical agent is usually alluvial, but also can be marine, aeolian, lacustrine, and glacial. And the mineral is usually heavy metals such as gold. So placer deposits may be formed in or by ordinary sediments process, heavy mineral accumulation, and sediments gravity separation. So this is because placer deposits has or having its different kinds of characteristics. It may be high in density or high dense, chemical resistance, and also mechanical durability. There are two general types of placer deposits. These are the residual placer and alluvial placer. So what is residual placer? Residual placer is, in effect, a concentration of gold or heavy minerals at or near its point released from the parent rock. In this type of placer, the enrichment results from the elimination of valueless material rather than from concentration of values brought from its outside source. So, in residual placer, it is the process of elimination. So, ini-eliminate yung gold sa kanyang pinagmulan. For example is the separation of golds into from a bedrock. Next is the alluvial placer. These are formed by weathering, transportation, and disposition of valuable minerals. The large alluvial placer platinum deposit at the Ural Mountain in Russia is an example of such deposits discovered way back in 1823. In general, these deposits are less consolidated, loose, and soft materials. So, ang alluvial placer daw po ay dahil sa weather, dahil sa transportation, at sa disposition ng mga minerals. So, these are the other types of placer deposits. First is the alluvial, which is the formal site of destruction. Diluvial, or found in the formal downhill. Proluvial, accumulation form at foot of a slope. So, matatagpuan daw po siya sa paanan ng slope. Alluvial, placer carried out by rivers upstream. So, in alluvial placer deposit or the types or the alluvial type, it is also the most important types of placer because it occur along the various places of the streams, and also its concentration is caused by the raging water. Then the bedrock material thrive once. As the concentration of the heavy materials occurs and the velocity of water lessens, it decreases its tire, and such as sediment get deposited, and finally there is a formation of some placer ore deposit. Lateral of beach. It is formed along the shore of lakes, seas, and etc. And of course, as we said, it is along the shore, so it is occupied by the ocean. Next is alien. It is formed by the action of wind, as the wind carries sediments from one place to another place. And glacial, it is by the activities of glacier. Fossils, placer or paleoplacer. Those placer deposits buried under younger rocks, so it serves as the evidence. So where do we find placer deposits? Typical location for alluvial gold placer deposits are on the inside bends of the river and creeks, in natural hollows, at the break of the slope on a stream, the base of an escarpment, waterfall, or other barrier. So, there are so many places where we can find placer or deposits. Maybe it is because easy to find and not that cumbersome to find. So which are the minerals at the break of the slope on a stream, the base of an escarpment, waterfall, or other barrier? So there are so many places where we can find placer or deposits. Maybe it is because easy to find and not that cumbersome to find. So which are the minerals that is found in placer deposit? Coastal placers, including those beaches, dunes, and on the continental shelf, have been mined for the gold, platinum, diamonds, the titanium-bearing minerals rutile, monazite, and ilmenite, casterite containing tin, magnetite or the iron, zirconium or the zircon, and the garnet, which is used for making a sandpaper. So I will show you some pictures of placer ore deposits. So in this picture, it shows the chemically resistant mineral, whether from a vein deposit moved downhill by mass wasting and are concentrated by the flowing water into the stream placer. Next is the picture showing the density sorting of heavy minerals during sediment transportation, forming placers between ripple marks. So next is the heavy minerals, which you can see the black, forming placers along the ripple marks. So how are minerals deposit being distributed? Placers are deposited behind rock bars, in the rock holes, below waterfalls, in the point bars inside meander loops, downstream from a tributary, along beaches, behind undulation on the ocean floor. So, as you can see po, marami po siyang lugar kung saan na-distribute yung mga placer ore deposit. So let's know why are the placer deposits important and why placer mining is bad. Placer mining is an important source of gold and was the main technique used in the early years of many gold rushes, including California Gold Rush. So importante daw pong ang placer mining dahil ito po yung nagiging source ng gold. But placer mining is usually aimed at removing gold from stream sediments and floodplains. It is because placer mining often occurs with a stream bed. It is an environmentally destructive type of mining, releasing large quantities of sediments that can impact surface water from several mines downstream of the placer mine. So, ayun na nga po siya. Kaya sinabi daw na bad yung placer mining kasi nga nag-o-occur siya ng environmentally destructive. So, for example po is, inalis natin yung gold sa bedrock. So, syempre, liliit na yung rock na yon, masisira na siya, na magkukos naman ng tubig, ng mas malakas na impact ng tubig na bumuhos sa mga stream. So, that's all for today, and wait, let me summarize up what is placer deposits. So, as I discussed, placer deposits came from the transportation, weathering, and by the gravity. Unlike the hydrothermal, it came from the magmatic fluid that caused high temperature to form it, the hydrothermal or deposit. The placer or deposits will be found in the streams, river, and mainly in the ocean or the shore. So, for more information, you can search for the source at the https at google.com. So, kindly search this source in order for you to more understand what are the mineral deposits and its origin.
This is the last origin of mineral resources, the residual or deposits. So ano nga ba tong residual or deposits? These are substances that are concentrated by chemical weathering processes. So ano nga ba tong chemical weathering processes? This is process by which rocks are broken down by chemical reactions. For example, when iron in rocks reacts with oxygen, it forms iron oxide, which weakens the rock. So, kita nyo naman yung difference dyan kapag nahaluan na or nag-react na yung oxygen sa iron. During chemical weathering, an original body of rock is greatly reduced in volume by the process of leaching, which removes ions from the original rock. Elements that are not leached form the rock does occur in higher concentration in the residual rock. So, gaya na nga ng sabi dito, during the chemical weathering process, the volume of the original rock is greatly reduced by leaching. So, yung leaching is the removal of valuable materials in rocks. So, here are the important factors in residual or deposits. First is the parent rock composition. Second is the climate. So, tropical and subtropical climates are favorable because they help in chemical decay. Number 3 is the relief. It must not be high to allow accumulation. So, sana ma-memorize nyo yung important factors ng residual or deposits kasi tatlo lang naman yan. So, let's proceed to the next slide. Common deposits are bauxites and nickel-ferrous lateries. So, yung dalawang yan yung common deposits sa residual or deposits. So, let's proceed to bauxites. These undergo through intense chemical weathering. So, ibig sabihin, extreme chemical weathering brought by prolonged rains in the tropics, leaching the common elements that include silicon, sodium, and calcium through leaching. So, ayun nga. Yung bauxite is nag-undergo siya ng intense chemical weathering. Yung ibig sabihin doon is dapat extreme na weathering sa paanong paraan, sa pamamagitan ng prolonged rains or continuous na pag-ulan sa tropics or sa lugar sa equator. So, ganito yung itsura ng bauxite. Yan yung nag-undergo ng intense chemical weathering. So, let's proceed to the next, the nickel-ferrous lateries. These are derived from the laterization of olivine-rich ultramafic rocks such as peridotite. What is laterization? Laterization is the condition of weathering which leads to the removal of alkalis and silicas that will result in a soil or rock with high concentrations of iron and aluminum oxides. So, ibig sabihin, laterization is the condition na naglaled sa removal of alkalis that neutralizes or effervesces with acids and silicas na principal constituents of sandstones and other rocks. Basta lagi nating tatandaan na yung bauxite is nag-undergo siya ng intense chemical weathering, while sa nickel-ferrous laterites is derived siya sa laterization. Ito yung itsura ng nickel-ferrous lateries. So we hope na naintindihan nyo yung mineral resources and its origin. So we have a trivia here. All minerals are not ores, but all ores are minerals.